two cars, both have the same 1.5 liter engine and both are naturally aspirated. Both use modern technology, but one produces more power and more torque. So how is that possible? Most people think if the engine size is the same, the performance should also be the same. But that's not how engines work. Because the engine capacity only tells you the size of the engine, not how efficiently it produces power. CC simply tells how much air and fuel the cylinders can hold, but power depends on how well that air is compressed, how efficiently the fuel burns, and how smoothly the engine converts that energy into motion. That's where engineering makes all the difference. First is compression ratio. Compression ratio means how tightly the air-fuel mixture is squeezed inside the cylinder before ignition. When the mixture is compressed more, the explosion becomes stronger and more energetic. This pushes the piston harder, which increases both torque and power. So even a small difference in compression ratio can create a noticeable difference in performance. Next comes airflow efficiency. After compression, the engine must also move air in and out smoothly. Because without enough fresh air, fuel cannot burn properly. Less air means weaker combustion, and weaker combustion means less power. So modern engines use larger valves, better intake design, smoother air passages, and low restriction exhaust systems. All of this helps the engine breathe freely. Better breathing means better combustion, which directly increases power output. Next is tuning. Today every engine is controlled by an electronic control unit. The ECU decides how much fuel to inject, when to ignite the spark, and how high the engine can rev. So companies tune their engines for mileage and smooth driving. Others tune for quicker acceleration and stronger performance. So even with the same hardware, different tuning can change the final power numbers. Power is also closely related to RPM. An engine that can safely rev higher produces more horsepower. Because the faster the engine spins, the more work it can do in 1 second. So if one engine revs to 5500 rpm and another goes to 6500 or 7000 rpm, the higher revving engine naturally makes more power, even when both engines are the same size. Finally, small internal design differences also matters. Modern engines use lighter pistons, low friction coatings, stronger materials, and smoother moving components. This reduces energy loss inside the engine. Less friction means more energy reaches the wheels instead of being wasted as heat, and this improves overall performance and efficiency. So that's why even if two engines are the same capacity, naturally aspirated, same fuel type, and built with modern technology, they still don't produce exactly the same output. Because power is not decided by size alone, it's depend on compression ratio, airflow, tuning, RPM, and overall design. In the end, engineering quality matters more than CC. If you enjoy simple and clear explanations about engines, EVs, and new technology, make sure to subscribe. I post more videos like this every week.